Experiments with stationary waves. This video looks at some of the ways we can investigate stationary waves. The waves themselves are covered in more detail on the videos Standing and Progressive Waves, Waves in Strings, and Harmonics and Overtones. Firstly, waves on strings. If a string fixed at both ends is plucked, a stationary wave will be set up, as happens in a guitar. Something like this. This is due to waves that have been reflected off the fixed ends are now travelling in opposite directions and superposing. Here we have the second harmonic being shown. Alternatively, one end of the string can be fixed and the other attached to a vibration generator, whose frequency can be altered using a signal generator. As we increase the frequency, initially we'd find the fundamental frequency, with the string showing a shape like this. This is also the first harmonic. Increasing the frequency further, the next time the string would show a significant pattern would be at the second harmonic, twice the frequency of the fundamental. Increasing the frequency further, we'd get the third harmonic, and so on. We can experience stationary waves with microwaves, having a microwave transmitter sending microwaves towards a metal reflector. We then have the emitted and reflected waves superposing. If we move a detector until it receives a strong signal, as it would here at the antinode, and then measure the distance till we get another strong signal, then the distance between peak readings would be half the wavelength lambda over 2. We can produce standing waves in a column of air, in this case this tube sealed at one end. We have a speaker connected to a signal generator. The frequency of the sound can be slowly increased, and the volume will rise whenever a standing wave is produced. The first one we get would be the fundamental frequency of first harmonic. Increasing the frequency further, the next we'd get would be the third harmonic. Columns of air sealed at one end cannot produce even harmonics. Another way of producing standing waves in a column of air sealed at one end is to use this arrangement. Here the length of the column can be changed and the frequency of the sound is fixed. We have a tube open at one end but placed in water, and now by raising or lowering the tube we can change the effective length of the tube. Again, the volume will rise when a standing wave is produced. As I said previously, the standing waves produced are covered in much more detail in the video entitled Harmonics and Overtones.